Dinosaurs lived during most of the Mesozoic era, a geological age that lasted from 252 million to 66 million years ago. The Mesozoic era includes the Triassic, Jurassic and Cretaceous periods. Dinosaurs arose from small dinosauromorph ancestors in the Triassic period, when the climate was harsh and dry. They faced competition from the crocline archosaurs for tens of millions of years, but finally prevailed when Pangaea began to split, Bruzat told Live Science. At this time, volcanoes erupted along the cracks of the supercontinent, causing global warming and mass extinction, he said. During the Jurassic period, 201.3 million to 145 million years ago, dinosaurs rose to dominance and some grew to huge sizes. For example, Vuivria damparacensis, the earliest titanosaur, dates to 160 million years ago. It weighed about 33,000 pounds, 15,000 kilograms, and measured more than 50 feet, 15 meters, long. Iconic dinosaurs from this period include Brontosaurus, Brachiosaurus, Diplodocus, and Stegosaurus. During the Jurassic, flowering plants evolved and birds, including Archaeopteryx, first appeared. There was a small extinction at the end of the Jurassic that we still know little about, Bruzat said. Even if dinosaur diversity was dropping, it's possible they could have bounced back had the asteroid not hit, Bruzat told Live Science. Dinosaurs lived on every continent, including Antarctica, and they filled different rungs in various ecosystems, from plant-eater to apex carnivore. Dinosaurs had experienced many rises and falls in diversity over their 150-plus million-year evolutionary history, he said. If the mass extinction hadn't happened, it's possible they would still be thriving today as more than birds. In the aftermath of the asteroid collision, long-term pain followed chaos. The collision caused massive destruction, including a shockwave, heat pulse, wildfires, tsunamis, including an immediate mile-high tsunami, volcanic eruptions, lethal acid rain and earthquakes. Dust and grime that the asteroid kicked up hovered in the air. This rain of hot dust raised global temperatures for hours after the impact, and cooked alive animals that were too large to seek shelter, according to Kruk. Small animals that could shelter underground, underwater, or perhaps in caves or large tree trunks, may have been able to survive this initial heat blast. The dust and particles remained in the air, blocking the sun for several years afterward and causing a nuclear winter that cooled the planet and led to the deaths of countless plants and animals, Bruzat and Kruk said. Smaller, omnivorous terrestrial animals, like mammals, lizards, turtles, or birds, may have been able to survive as scavengers feeding on the carcasses of dead dinosaurs, fungi, roots, and decaying plant matter, while smaller animals with lower metabolisms were best able to wait the disaster out, Kruk previously said. Moreover, the asteroid also pulverized carbon-rich rocks, which released carbon into the atmosphere and led to global warming for a few thousand years, after the nuclear winter ended, Bruzat said. Scientists used to wonder if the Deccan Traps volcanic eruptions in what is now India played a role in the mass extinction. But recent studies show that the Deccan probably had very little impact, Bruzat said. It was most likely an innocent bystander. The asteroid is what caused the extinction.